Alright, welcome back everybody. Today we are going to talk about the opposite of exponential growth. When we talk about exponential growth, we talk about from left to right, this uh, curve or this Nike swish that I kind of referred to was going from left to right, increasing. But now we're talking about that Nike swish decreasing from left to right. So it's a curve that starts up high and curves down low like you see the picture um, on your left hand side. Okay, so um, like I said, we're going to start up high and come down low. Now this is very similar to the exponential growth model that we talked about. We're still going to have an A value, we're still going to have a B value, we're going to still have an X value. So everything's the same. So our A value, like we talked about last week, our A value is going to be our initial value. Okay, our initial value, good. Our B value is going to be now, it's not going to be our growth factor, but now it's going to be our decay factor. Our X is still going to be our input, and our Y is still going to be our output. Okay, good. I don't know why these boxes are coming up. Let me get rid of those. Get rid. Good. Alright, there we go. Okay, now the only difference is now that this B value is going to be something different. So this B value here, now if you remember our growth model, that B value had to be above 1. Okay, but if you see here, our B value has to be below 1, but it has to be between the numbers 0 and 1. So it has to be a decimal or a fraction that is between 0 and 1. So an example of that would be the B value could be 0.5, right? Or it could be 0.25, something like that. Okay? Alright, so let's go through a couple examples. It's going to be very, very similar to our last section. So it's just going to say, is this a growth or decay? Now remember, when we're looking at if it's a growth or decay, it's going to determine whether the B value is going to be above 1 or between the values of 0 and 1. So let's look at number 1 and let's look at that B value. So that B value is going to be which number, the 2 or the 0.1? Whatever number is being raised to the x, in this case it's 0.1. Okay, is that number above 1 or between the numbers 0 and 1? If you're looking closely, it's between 0 and 1, so this would be a decay. Awesome, cool. Okay, now let's look at the next one. What is our B value here? B value is the number that's being raised to the x. In this case, it's 1.8, right? Now, is 1.8 above 1, or is it a number between 0 and 1? Okay, think of it like money, like 1 is $1. Well, this would be $1.80, right? So this would not be a decay model, but actually, what type of model is it? We talked about last section, and this would be a growth. Oh, let's try that again. Growth model. Okay, good. Got to work on my penmanship here. Good. All right. And lastly, let's look at our um, growth or decay factor here. So our decay factor is going to be the number that is being raised to the x. So the number that's being raised to the x is 0.99. Now this is a little tricky one. Now is 0.99 above 1 or between the numbers 0 and 1? Think of it like money. Like this is 99 cents, so it's not quite a dollar. So this is actually below 1. So this would be a decay model. Okay, awesome. Okay, we're going to kind of get into the A value, the B value, and C value um, next next slide. Okay. So this is going to be very, very similar. So, looking at the equation itself, our b value is what's being raised to the x, and that's going to be our decay or growth factor. In this case, this is a decay factor, this is a growth factor, this is a decay factor. And the other number is our initial value or our y-intercept. So the easy one is a, right? The easy one is just to say, okay, which number or which ordered pair has 0 as the x coordinate. So if you're looking at this first example, 0 has the x coordinate. So the whole purpose here is that we want to write an equation in exponential form given a table. So we're given a table like I said, and 0, comma 16 is our ordered pair that we're looking for. So our a value is going to be 16. Cool. Now, our decay factor, okay, our b factor, is going to be, what are you multiplying every time, right? We talk about exponential forms, and exponential forms are what are you multiplying every time. So here you're going to say, okay, well, what can you do to 16 to get an 8? Okay, or what can you do to 8 to get a 4? Now, if it's something that you cannot see easily, remember our method to divide backwards. That's going to be an arrow going down. Okay, let's kind of draw that arrow again. Divide backwards. There we go. Okay, so if we're going to go over to our calculator, let's type in. Now, last section, okay, you might have made the mistake to divide 8 by 16, but I need to divide, or sorry, if I divide 16 by 8, what we want to do is divide backwards. I drew my arrow upside down, actually. Here we go. Divide backwards that way. Okay? So if I divide backwards that way, I want to divide the 8 by the 16. So I'm undoing what's happening. So you can either say, what am I multiplying by 16 to get 8? Or what do I have to, so what am I doing to divide backwards? So I'm going to take my 8 and divide it by 16. And what do I get? I get 0.5. Okay, so that 0.5 is going to be our decay factor. So you could say 0.5 is going to be our decay factor. So that is our common multiplier, right? 0.5, 0.5, 0.5. So if you multiply 16 by 0.5, you're going to get 8. If you multiply 8 by 0.5, you're going to get 4. If you multiply 4 by 0.8, you're going to get 2 and all the way down. Now, if you remember, our exponential model is going to look like y equals a times b to the x, okay? Where a value is our y-intercept, or b value is our growth factor. Easy. All you're going to do is put them together. So let's try that. So it's going to be y equals our a factor, which is 16, our b factor, which is 0.5. I'm always going to put those in parentheses. Okay, and then we're going to raise it to the x. Okay, that's all we're going to do. So let's try 2 and 3, both money problems. Okay, pause the video and good luck. Okay, the last part of this section is going to be dealing with graphing. We already dealt with graphing last section with exponential growth models, but like last section we talked about the curves going upward from left to right. Okay, now we're going to go opposite. So these are going to be decreasing from left to right, going downward like that. So all of your graphs should look something like the right curve. Okay? So for these, we're just going to pick a couple of values. So I'm going to pick 0, I'm going to pick 1, I'm going to pick 2. Okay? So all I'm going to do is take those values, plug them into my equation. I'm going to get an order pair, and with that order pair, I'm going to go ahead and graph. So For this one, it's going to be 6 times 0.5, okay, raised to the 0 power, okay? Okay, well, what is 0.5 raised to the 0 power? Well, if you don't know that off the top of your head, you put it into your calculator, so it's going to be 0.5 raised to the 0 power. Hit enter. That's actually 1. Well, if you remember back to your exponential or exponent laws, anything raised to the 0 power is 1. So this, when you raise 0.5 to the 0 power, is going to be 1. But don't forget, this 6 next to these parentheses means to multiply, so then I have to take 1 and multiply it by 6. Well, 1 times 6 is 6. So when I input a 0, I output a 6, so my ordered pair is going to be 0, comma, 6. Awesome. Okay, let's try this again. Next one I'm going to do is 6 times 0.5 raised to the first power. Yeah, that's a little 1. 1. Okay, 1. Okay, now 0.5 raised to the first power is 0.5, right? We should know that. Now don't just put a 0.5 here, right? What do you have to do after you raise it to the exponent? Orders of operation, multiply. So we need to take our 0.5 and multiply it by 6. So take your 6, okay, multiply it by 0.5, and what are you going to output? You're going to output a 3. So I'm going to input a 1, I'm going to output a 3, and that ordered pair is going to be 1, comma, 3. Cool. And lastly, let's input a 2, so it's going to be 6 times 0.5 raised to the second power, or squared. Remember PEMDAS, let me just write that up top. Okay, parentheses, nope, exponents. Okay, so exponents, I have my 0.5 raised to the 2. Okay, 0.5 raised to the 2 is, well, what is that? Let's plug that into the calculator. 0.5 raised to the second power is 0.25, right? Is that my answer? No, right? Because we have to do what? Okay, we have to multiply. So when we take the 0.5 and multiply it by 6, so 6 times, I'm sorry, 0.25, okay, hit enter, and our answer is 1.5. So when we input a 2, we're going to output a 1.5. Okay, so let's go over to the graph and graph these. So my ordered pair is 0, 6. It's going to be all the way up there. Cool. Okay, 1, 3. It's going to be right there. And I have 2. 1.5 is going to be right in the middle right there. So now you can see our curve kind of curving towards the x-axis. Now what's important is that this is going to curve, but remember, these are the ones we're going to deal with are never going to cross the x-axis. So from left to right, we're going to draw our Nike swoosh, decreasing, there we go, from left to right, and it's going to look something like that. Okay, so that's our exponential model graph. Just plug in a value, okay, see what you output, create an ordered pair. Okay, last one is all yours. No problem. Okay, good luck, pause the video, and I'll see you next time. Thank you.